Next, uh, I'm going to discuss about column head and drop dimensions. Now, my last slide, I discussed about what is column head, what is drop dimension. Now, if you want to model the columns, column head or drop dimensions, or if you are going to analyze by manual calculation also, then you need to find out the dimension of column heads and dimension of drop panel. How you can find out? You can find out using this formula. DE, what is DE? Already I explained my last slide. To find out the dimension DE, you can use this formula 1 by 4th to 1 by 5th times of Lx plus Ly by 2. Now I just explain here what is Lx and Ly. Okay. Suppose this is your columns. This is your columns. So this is center to center dimension Ly and center to center dimension, this is Lx. So to find the dimension of drop panel or also column head, what is the formula? 1 by 4 to 1 by 5. You can take 1 by 4th and you can take 1 by 5th also. Lx plus Ly by 2. Okay, so this is formula to find out the dimension of column head. Now to find out the dimension of drop panel, if the column is interior column and the drop is interior drop panel, then you can use Lx by 3 into Lx Ly by 3. That means nothing but to find out this one, you use Ly by 3, and to find this dimension of drop panel, you use Lx by 3. Okay, so from this you can find out drop dimension, internal drop dimension. Now, if the drop is in external, then how you'll find out? The external drop is look like that. Suppose in case of this kind, suppose your edge there is a column. Okay, so you need to provide a panel also, drop panel. So how will find the dimension? To find the dimension, center to center distance of column divided by half, whatever this center to center distance, that half you have to consider to dimension along y direction. And also if this is your center to center distance Lx, so for this thickness of drop panel, sorry, this in x direction, the dimension of panel is nothing but Lx by 2. Okay, so this is for exterior panel, this is for interior panel. Next, in next slide, I am going to discuss about two very important term of slab topics. It's nothing but column strip and middle strip. Please try to understand this both the terms, because if you have confusion on column strip and middle strip, how we are find out and what is this, then for detailing and for analysis, for calculation the moment and distributing the moment, and also for detailing time also, you will face lots of problem. So please try to understand very important terms, what is column strip, what is middle strips. uh, what is middle strip, sorry, what is column strip? First we'll go with column strip first. So what is column strip? Column strip is nothing but the strip with width of 0.25 times of shorter dimensions each side of columns. Okay, is nothing but, suppose this is a column center line. If I show, if this is your column center line, then both side shorter span by, suppose lx is your shorter span, both side lx by 4, this side also lx by 4. This is the width of what? Column strip. Now this is the one column, this is one column, this is one column, and this is also one column, four column. So column strip is nothing but width of either side is how much? Lx by 4 from the center of column. So total width of column strip is shorter span. I'm saying Lx is my shorter, so that's say Lx by 2. This is your total width of column strip. Now what is middle strip? Middle strip is nothing but the strip which is bounded by column strip. Okay, so next, if sometime you will be confused, like sometime you will confuse, like they are giving here 0.25 of L2. Okay, and here also they are showing 0.525 of L1. This is very confusing. If you read this line, you will understand this a little bit confused. Confusion is there, so don't think about L1 and L2. You always remember the column strip is 0.5 or 1/4 of shorter span. This is your column strip from center line. If you want to find out the total width of the column strip is nothing but half of shorter span. Half of shorter span. Okay, you just try to remember. But the condition is it should not be more than 1/4 of longer span. Whatever longer span, it's maybe Lx, it may be Ly, and shorter span, it's maybe Lx, it's maybe Ly. So it should not be greater than longer span. So please try to remember. Okay, I am not showing here L1 and L2 because it is a little bit confusing. I am saying shorter span and longer span, so it will be easy to remember. Okay, now what is panel? Panel is nothing but uh, the area which is bounded by center line of the column. So suppose if I say what is the panel of here, the panel is this one. Here the panel is center line, center to center. I'm taking, this is the panel. Okay, this is one panel. Maybe if there is another column, so there is another panel. So that is panel, that is column strip, and this portion is middle strip. Okay, I hope you understood. Next, I think here we discuss about all the terms what is required for slab analysis and design. Now we will go for advantage and disadvantage of flat slab. There is so many advantage and disadvantage also. You can, if you go any books or if you refer any paper or something, you will see so many advantage and so many disadvantages also. From this I collected few advantage and few disadvantage. Simply see, if you use the flat slab, it is very easy to construct and very fast, and also it is very easy for MEP work. Okay, plumbing and mechanical and electrical work also it is very easy. And if there is any height issue, suppose your the floor to floor height is less, that time you can use flat slab. It is very it's helpful if you use flat slab. And a flat slab is easy to construct because we no need to shuttering for beams, and you just shutter after column construction, you shuttering for slab, and at a time you construct. So it is easy to construction also. So that's why it's simplify for formwork. And also it is economical after if the uh, if the economical of it's also economical if we limit the span length is 11 meter. Up to 11 meter, it is that span length, if it is up to 11 meter, then it is economical. But there is some disadvantage also. And it is disadvantage if your gutter level height, suppose your gutter level height is sorry, your stiffness you are not achieving. Okay, somehow you are not achieving the stiffness. That time flat slab, it is one, maybe one kind of issue, because the stiffness of flat slab to column connection compared to the beam column joint connections, compared to it is less. So stiffness one kind of issue in flat slab system. And also flat slab is economical, and flat slab is taking significant effect, giving significant effect for middle rise and low rise building. It is not giving it is not participating to resisting the lateral loads in high rise building, or lateral loads, maybe earthquake or wind loads. So that is also one kind of disadvantages. So there is few advantages and few disadvantages. Now next, I think here I am going to finish my first session or first lecture. Next lecture I'll come with very important thing, that is analysis. And a different method is there to analyze. So please check my next video if you're interested to how to we are analyze this flat slab, because still till now we are discussing about the different terms of flat slab, like column heads, drops, how we are find out the dimension of column heads, how we are find out the dimension of drops, and what is the advantage and what is the disadvantages. So we discuss and different types of flat slab systems. But now we are going to find out how we are now we are going to discuss how we can find out the moments, what are the methods to analyze the flat slab. So please uh, watch my next video in lecture 2 to get idea how we are analyzing the flat slab systems. Okay, thank you.